Hey, I'm Josh, and for my project, I made what I'm calling the shower bottle inverter. Let me explain. My motivation to create this prototype was to solve the problem of my shampoo and body wash bottles always falling over in the shower when I get down to their last few squeezes. Sometimes the funky geometry of the bottle itself would be at fault, and other times it was the severely limited shelf space in my shower. In any case, I knew this was a product that America needed. After some iteration, this is the design that I ended up with. The first component that I set out to make was the base. I was initially planning to make the base out of aluminum, but I switched to acrylic so it wouldn't rust after exposure to water. To create the workpiece that you're seeing here, I cut an oversized piece of acrylic sheet that I found in the wood shop to the 10-inch by 4-inch size that I wanted using the horizontal bandsaw. To get rid of the sharp corners, I added some fillets using the belt sander. Once my plate was cut to size and smooth along the edges, it was time to add the holes. First, I used a 1¼ inch hole saw at just under 200 RPM to create the 3 large holes along the center of the plate that would hold the bottle caps. I then used a 3/16 inch drill bit with the mill speed set to about 1800 RPM to make the 2 small holes near the edge of the plate. Once this was complete, my base was done and ready for assembly. Next, I tackled the 2 arms that mount the acrylic base to the shower wall. I thought a resin casting operation would be perfect for these parts since their geometry is a bit more complex and because it would be my first time attempting a resin cast. To create the mold, I borrowed access to a friend's 3D printer and printed the arm out of PLA resin. I then made a small cardboard box lined with duct tape to serve as my vessel for holding the pattern and pouring the silicone mold. Next, I mixed the mold solution, poured it over my pattern, and let it cure for about a day. I decided to add that extra wall to my cardboard box in order to help conserve the mold material because I wanted to make sure that it fully covered my pattern. The mold turned out well, so it was time for the resin cast. I carefully filled the mold with the resin mixture, then let the cast sit for a bit over 24 hours before removing it to ensure that it was fully cured. The casts came out a bit rough around the edges due to some imperfections in the mold, but the critical dimensions and geometry of the arms were captured perfectly. To attach one suction cup to each arm, I used an adhesive specifically formulated for joining plastics. From a manufacturing standpoint, I recognize that this isn't the best approach, and I do have some ideas about how this step could be done differently in a high volume production context, but for prototyping purposes, this adhesive worked just fine. With the epoxy resin arms and the acrylic base complete, the last step was to add the cord system that would both help to keep bottles from falling over and keep the arms from sagging once attached to the shower wall. The cord stops were a bit finicky to work with, so I didn't get great footage of this process, but this component was pretty straightforward as it simply involved cutting the parachute cord to length, threading the cord through the base and adding cord stops, and then tying off the slack in a knot. And with that, my prototype for the shower bottle inverter was complete. There are definitely a few things to clean up in the design before I take this thing to market, but with the engineering ingenuity that's clearly on display here, I'd say this concept is dripping with potential.